A warm good evening to everyone. It's an absolute pleasure to welcome you all to this webinar series on the topic drones and AI. I am happy to invite Mr. Leo Peter Charles as well uh, to host the next coming as is the speaker of the day, and as well as I would like to give a brief introduction on Mr. Leo Peter Charles. Mr. Leo Peter Charles is an avid aero modeler and a drone platform evangelist. He has a bachelor's degree in aeronautical engineering from MVJ College of Engineering. He's also a serial entrepreneur who has the experience of having startups in the IT, hobby retail, and UAV training industry. He has trained more than 5,000 plus students in aero modeling in his career spanning 6 years now. He also had the opportunity of training 100 plus drone pilots for the drone industry who are now employed in 15 plus companies. Leo, Leo Peter is the aerospace consultant for various academic institutions like VIT Bhopal, MVJ College of Engineering, Agni Tech College of Technology. He is also an aerospace consultant for many companies. Mr. Leo Peter Charles completed his journey as the CEO of Garuda Aerospace Private Limited recently. This was JMA's first project as a part of the JMA Ecosystem Support Endeavor program. The company became India's largest drone service company and became one of the three drone companies invited by NDRF to assess them at the Uttarakhand glacier disaster site. Leo Peter Charles formed Jain Aerospace Private Limited in 2019. JMA is a startup ecosystem whose primary purpose is to assess the aerospace industry in scaling up. JMA is the evangelist for the aerospace industry, especially the drone ecosystem, and strives to link the dots to complete the picture. JMA has worked tirelessly to raise awareness, provide infrastructure support, test site access, provide a skilled aerospace workforce, provide business solutions, train students for Industry 4.0, and foster industry academia collaborations. JMA so far has conducted more than 200 workshops, professional talks, webinars, and seminars in numerous top institutions, colleges, and organizations to help give an insight into the industrial workings of the drone and aerospace sector. JMA has currently trained 61 drone pilots so far, and all of them have been successfully placed in the top drone companies pan-India. I kindly request Mr. Leo Peter Charles to present us with the topic.
Thank you so much, Praveen, for the introduction. It's indeed an exciting space to be in at this point of time, where drones are taking over literally all of the manual tasks humans were doing. And I'm just not talking about aerial drones. I'm talking about ground-based bots, water-based drones, even submersibles. That way, we are in the era of full-fledged autonomous vehicles. I think recently a lot of people would have seen Domino's having an autonomous pizza delivery cart. So most of manual labor that is very easy to automate will go into the hands of drones, and then we will move on to higher purpose or higher work, as people call it. This is the college webinar series as part of the JMA ecosystem support endeavor looks or aims to instill a curiosity in people so that they could participate in the entire movement of making drones solve day-to-day challenges that are easy, or either ways, if you look at it, are difficult for humans, in the case that it might be hazardous or time consuming, or it might be very costly to perform. And artificial intelligence has taken this to another level altogether. And today we will see how AI and drones have come together to make the world a better place. And I have a humble submission. I am also learning about AI. My background is in aeronautical engineering. I did not graduate in computer science. I had a small stint at IBM for 2 years where I got introduced to AI when I was the IBM's Watson ambassador. And also when we did cognitive analytics for the quality department. And that's where I learned about IBM machine learning, natural language communication, and all of that. It was really exciting, and that's when I got glued to the entire concept of artificial intelligence and intelligence that's outside human body or organisms. So we'll go through it one by one. Next, Praveen. Praveen, if you could go for the next slide. Yeah, the future is autonomous. So that's me. I call myself a dronepreneur. Praveen's done an introduction. I graduated from MVJ College in 2013. That's my alma mater. I had the privilege to study under Air Commodore S.C. Gupta, former director of CEMILAC. It's a government organization under DRDO that approves all the aircraft designs that the Indian Armed Forces use. And I've been building unmanned aircrafts right from when I was in college. So drones is my hobby, business, and passion. Very rarely for someone, all of the three comes together, and I think I'm privileged for that. And I call myself a dronepreneur because I believe drone is has solution to a lot of challenges that we face. So I keep making this statement. Drone applications are limited by human imagination. Somebody thought they could put drones in Mars, and today we have multiple sorties going on. And the saying that sky is the limit is no more valid. I think the sky is just the beginning, and we have a long way to go. And AI definitely is playing a part in that. I've been in IBM. After that, I've had multiple enterprises where some of them built successfully, some of them failed. And Jane Aerospace is my recent company that I've started. Next slide, please. So these are the topics that I will be covering. We'll see a small introduction to drones just to get clarity, and then when actually did drones start? What are the different types of drones? We would have seen a particular four-rotor drone in most of the events, but then there are multiple types. What's AI? What are the companies that are using AI? What are the different applications? Very, very interesting applications. How is the Indian ecosystem for this? I'll talk more about my company in the end, and the two programs that we are running to build the ecosystem apart from our other consultation services. Next slide. Next slide, please. So what are drones? Drones are any object or any vehicle that is remotely controlled. It can be a flying machine, it can be a vehicle that moves on the ground or above water, or even a submersible. Anything that's remotely controlled with no human pilot on board is a drone. We specialize, or my specialty comes in the unmanned aerial vehicle or the UAV segment. So these are vehicles that fly, which are remotely controlled through a ground control station, and there may or may not be pilots. Soon I think pilots also will go away because of AI, and it's controlled through a command and control link, generally a 2.4 or a 5.8 gigahertz frequency band. And drones initially started with military applications and later moved on to commercial segment. And that is where we've been seeing applications explode, right? It started with normal photography, then videography, and then we came into high-end cinematography, and then we moved to agriculture, mapping and aerial mapping and surveillance, and then we moved to contact-based ultrasonic thickness inspection, thermal inspection, tracking, uh, and I think that list goes endless. When I was reading, and then somebody said there's 200 applications. You can literally do exhaust gases analysis. You can do so in the high power transmission subject. You will see something called Corona, where you study the insulating connectors between two high tension wires and see if it's working right. So you have some a device called the Corona camera that can detect the halo around the insulating device and then see if it's healthy or not. So even that's on drones now. Then LiDAR came in for high-end 3D visualization. And somebody put a bathymeter. A bathymeter is a device that helps in understanding the depth of water bodies. They put it on a UAV so that they could map rivers. And drone delivery is one, and going forward we might see asteroid mining, interplanetary logistics. All of this is very much possible. Next slide, please. So what's the history behind drones? So that's another thing that we will have to look at. You would be surprised to know that the first drones, or something that is closely relatable to drones, started way back in 1849 when Austrians tried to attack Venice. So they had these hot air balloons that were filled with explosive, and then they tried to move it over Venice and then drop those bombs. Unfortunately, due to wind conditions, those balloons came back. That's what's the story. But then that's where it started. So people realized that it is possible, if you could control a device from a longer distance, that you could fly it remotely. And that's when it started. Again, in World War One, we see the British developed the Archibaldo. It's like a targeting system for aerial practice, rocket powered. That system was used for target practice. So that is also a drone. It is initially controlled with preset trajectory. And from there, then we see the Curtiss N2C2 drone, sorry, way back, they started in the 1930s, and then 1937 they finished it. That drone is the first of its class where it was fully remotely controlled and was used for surveillance. And we also see in the 1986 that RQ-2 Pioneer, the precursor to the Predator and the MQ-9 and all of them, that had a full-fledged multi-optical payload, which had both electro-optical, that's your normal camera with zoom and all of that. Then it had thermal payload as well, and it could be controlled via satellite. So that's the first time where drones could really be used in warfare. And then we've seen many after that, and in most of the movies today, I don't think any war movie today comes without a drone, at least the latest ones. And the last airstrike was on General Soleimani of Iran, where they took out his convoy near the Baghdad airport. So, and India recently also purchased on lease 3 MQ-9s from General Atomic. So that way, we are seeing a large use case of drones in the military and in the commercial segment. And today, it is possible for everybody to own a drone. A toy drone roughly costs you about 2,500 rupees on Amazon. And if you want to have like a normal drone experience, you could always buy it on Amazon and then use it. So this is the brief history. It's more detailed. I request all of you to take some time and go through it. It's available on the internet. But then these are the major places where, or major turning points where drone technology actually grew. Next slide, please. So these are the different types of drones. So most of you might have seen the multi-rotor, but then we have so many types. We have the fixed wing. That is what the drones generally started with. It looks like a normal aeroplane. Then we have the single rotor drone, part of the rotary wing family. This looks like that's a helicopter. You have multiple payloads for it. Then we had the multi-rotor drones. This is what truly revolutionized the commercial drone segment itself. And the multi-rotor drones, apart from the tricopter, all come in even number of rotors. So you will have quad, hexa, octa, and so on and so forth. Now, if you take the first three, the fixed wing, the the heli, and the multi-rotor, they are like the primary ones. Now, out of that, a lot of other things also got derived. Now, if you see a fixed wing drone, it has a longer endurance time. The multi-rotor drone has a vertical takeoff and landing advantage. You don't need a runway for a multi-rotor, but you will need one either for landing a fixed wing or for both taking off and landing. And then both of this was put together to create the hybrid VTOL, which can vertically take off but fly like a fixed wing. And apart from that, we have the ornithopter that flies like a bird. You might have seen this in the movie Uri, but this actually exists. This at the moment is being used to scare away birds on large agricultural lands because it is designed in a way of a predator. That's a peregrine falcon design. And it is also used at airports to scare away birds so that the aircrafts don't have any bird strike. Now, the last format is the aerostat. The aerostat uses buoyancy. You would have seen hot air balloons or helium balloons. So it's the same concept, but then it is powered and can stay afloat for long durations of time. And then you have cameras and all of that to perform surveillance. It's best suited for border surveillance because it can be up there for multiple hours. Next slide, please. Artificial intelligence. So this is a very nice concept, a lot of misconceptions around it. I will try to explain to the best of my ability. So artificial intelligence is basically a computer trying to mimic human brain. So how does that basically work? Now, if you tell a kid or a baby, don't touch fire, that's a direct command, right? If the baby does not understand that, it will still go touch the flame and it might burn its finger. But now there's a feedback that the baby's brain has already got, that if you touch fire, you will burn your finger, which is bad because you will feel pain, right? Now, with this, the baby has learned that it is not supposed to touch fire again. Artificial intelligence works in a similar way, where a feedback loop or a feedback network helps its algorithms to evolve. Evolve would be a very liberal term. It's algorithms to adapt to changing environments. And this is done through various methodologies where different levels of programs stacked over one another take into consideration what each outputs are and then try to give the final output in a different way based on the data set it acquires. So the process, this entire thing is called artificial intelligence. Major thing is learning, reasoning, and perception. Perception is also very different for a lot of people. Now, in this majorly, we have machine learning. So in machine learning, what happens is computer programs adapt to new data without our intervention. So let's say if, for example, let's say there's a small circle and a ball of X diameter can only pass through it. Now, if you increase the ball's diameter, we write that the circle's diameter also has to be increased. So as and when the ball's diameter increases, circle diameter is increasing. Nobody is going and inputting any other kind of instruction. In a software, generally you will have a normal software program, you will generally have to do this. But here, the computer does it by itself. This is a very, very simple example. Now, there are more complex situations where you will have to have multiple algorithms working one after the other or simultaneously to understand the very dynamic environment outside to give a valid output. Now, an example for this, in IBM was working with a company that was producing robotic prosthetics. Now, let's say somebody is an amputee who has lost his leg below the knee. The knee, the shape of it, the liquid that fills it, and the ligaments, all of these are millions of years of evolution. You can't simply make a robotic prosthetic and think that it will work all well. Now, what they did is the doctors used to use the IBM Watson computer and the program in it, and slowly evolved the design of the knee socket itself. So they would actually put the robotic prosthetic on a patient, and as and when the patient kept using it, they would study the pressure points, the vectors, force vectors on it, and they would slowly change the design of the ball and socket arrangement of the knee itself. Now, that would have not been possible if this was not there, because every time somebody would have to come in, you would tinker something, but you will never get real-time data back, and with that it would not be possible. Now what, let's further this example. What deep learning does is, let's say you put this robotic prosthetics on 1 lakh people. So apart from the force diagram, pressure data that you get, you also get geography data, humidity, corrosion, how different the geography is compared to the plains and hilly terrains, because people's physique differs from place to place, right? And how fast people put on weight or how fast they're losing weight. Based on this, you could generate an entire data set of designs for robotic prosthetics. So this is one part. Now, this is through different types of sensors, but the main type where it is also the other way to sense this would be computer vision, where you take pictorial or video data, feed it to the computer, and then analyze it and help the program evolve. The best example would be obstacle avoidance. Now, let's say a car has cameras on all sides, and it is autonomously driving. The only way, there are 2 ways or 3 ways you can avoid collision. One would be based on radio. The other would be based on LiDAR or visual images, right? So now, if you take a photograph of how close the car is or how far the car is, the computer starts learning. So which is safe, which is danger level 1 or danger level 2, and which is a situation where there is zero probability of any accident. So this is computer vision. So where the computer, like our eyes, is trying to understand the outside world and give output based on the visual information it receives. Deep learning is a subset of machine learning, and computer vision is one way of data being processed for the part of artificial intelligence. Next slide, please. So what do you see on the top programming languages? These are the 5 major. There are other minor languages as well: the C++, Java, Python, Lisp, and Prolog. These are the languages generally used to write the algorithms for AI-based computing. And you can pick any one of this based on your use case. Python is generally used for IoT based applications where AI is used, and C++ is the basic of all. So you want to build something from scratch where you want to have full control over it, you can always use C++. Next slide. So drones and AI. So what exactly drones and AI come into picture? Now, one place where drones and AI come into picture is machine perception. Now, what happens is when we say an autonomous mission, let's say we are mapping or we are inspecting some object. Now, the drone should be able to perceive distance, depth to avoid hitting that obstacle. It also should be able to create trajectories around the obstacle so that it can move in the right direction to get the maximum amount of data or valid data that can be used for processing. Now, apart from this, it also needs to capture the right data set that can be sent back to a computer. Either the computer can be on board the drone, the computer can be on the ground station, or it can be a standalone computer somewhere else where the data goes so that you could build a useful output from it. Let's say here, for example, you can see the number of cars. This is a mapping image. So the drone is flying above and it's taken we call it a nadir image. It's a 90, the camera is 90 degrees down. It's taken a picture. Now, this needs to be sent back to the computer with the program which has AI so that the number of cars can be counted. You can count the number of cars, you can count the number of cars that are white, you can count the number of cars that are black or any other color. So this is computer vision for the drones. This can be done real time as well, as we will see in some of the examples, or it can be done post data is transferred to the computer. Now, what happens with machine learning is when the drone is able to evolve, when ML programs are inbuilt into the drone, drones can better evolve trajectories. One. Second is they can better plan their the photographs that they take. They can judge lighting. So there is this drone called Helios 2 that is used to inspect boilers or chimneys, but the drone flies inside the boiler, so it's not flying outside. Now, once you're flying inside the boiler, there's no lighting, right? So the drone has 10,000 lumens LED lights that light up in such a way that there is no shadow that comes when the photograph is taken. And also, these lights help the drone to avoid collision with the walls of the boiler or chimney or any internal inspection that is going on. And since we've seen deep learning as well, a lot of drone companies gather data from the drones that we are using and tend to build better drones later. So if this is one case. Now, let's say the Metris 300 RTK from DJI, one of the most advanced commercial drones that is available, that was built over a period of time from all the data that was delivered to the DJI company from their previous models that were released. Apart from this, deep learning also enables to create swarm drones, where the large amount of data for trajectory, collision avoidance, and object detection is built into the AI program, and multiple drones can operate simultaneously. And with deep learning, you also have different layers of algorithms or networks that are present so that the decision process is divided, like how we use different parts of our brain to make certain decisions. The same way, this is also built to mimic the human function. Next slide. So this is a classic example of how drones and AI are being used. Now, here, if you could see, this drone is performing the inspection of this windmill. This can be done manually as well, which I have done. It can be done manually, but how do you do it autonomous? Now, why do we need to do it autonomous, you may ask? To do it manually, the problem is parallax. When you're flying it, you're standing on the ground. The drone is at a different coordinate system. So you will have to perceive the object from your coordinate system as well as the drone's coordinate system, which is a very, very difficult task. Now, if we automate this entire process and say the blades need to be captured at certain distances, the front and the back, then you capture the hub, then you capture the mast. So once this is the planning, so we've planned this. Now the first initial thing we plan that it will first go up capturing the mast, it will revolve around the mast at certain height, then it will go around the hub taking pictures at certain intervals, and then it will go up and sorry, it will go up and down the blades taking pictures. This is like the initial input that you give, and this needs to be perceived by the drone. So the drone will have obstacle avoidance sensors so that it keeps a certain distance from the mast, and this is fed to the computer. It will have a barometer to measure the altitude, and it will also have a GPS to measure where it is on the planet. So it needs all of this, right? So with all these inputs, it knows what it is doing and where it is going. Now whether is it good to fly the drone 5 feet from the blade or 10 feet from the blade, it's what we gain when we fly manually through experience. Now, how does the computer learn this, right? So if next time when the second time when you input, you give it a closer, so you say the obstacle avoidance distance should be 3 feet, and then the drone flies at that distance. If it senses that the drone is going too close to the obstacle at multiple junctions, then it says, okay, at a probability rate, this might even collide. So it will say, okay, 3 feet is not the right thing. Let's go back to 4 or 5 feet. So that's how you build the algorithm. Now, the photos taken as part of the computer vision part of the AI goes back to the computer where it is processed. So you can see if the paint is worn out, or if there are cracks, or if there is stress marks or rusting. All of this can be spotted. So initially you will have to spot with the computer, and once as and when you keep on going, you can take it forward. You can take it forward. The AI will start learning how to process this without your intervention. So the first is motion for drones, motion planning, then you have machine perception, and then you have computer vision. This all together bundled creates a AI algorithm that the drone can continuously develop to become more efficient. Next slide, please. So this is a very small flow chart from bottom to top that that shows different industries that use this, and how drones help, and then how live data and process data are used or processed using AI. Now here you could see the industries of construction, transportation, energy, insurance, agriculture, and public welfare or public department. So that way, these are the industries. That list is really long, but for the ease of understanding and for the limitation of time, we've kept it short. The drone is the device that does data acquisition. And for data analytics, we have intermediary softwares. And the process data can either be live, real time, or can be processed at a site and then the results delivered. Now, in Australia, they've recently launched a program where they are using drones to spot sharks and alligators in the waters. Australia has that problem. So these drones help spot sharks. Now, how does the drone know how a shark looks? So with computer vision, you have the skeletal of the shark that is fed into it, or different images of sharks that are fed into it. So, and a shark that is swimming on at the surface of the sea or the ocean can be spotted, and the computer recognizes it. Every time you say that it is a shark, and then you take an affirmative action on that, then the program learns. Apart from that, in agriculture or in insurance, in agriculture where we use AI for crop management, we have multispectral cameras that are attached to drones, which take pictures of crops, and then we understand if the crop is stressed or not. It can be stressed due to diseases, due to pests, due to lack of fertilizers, improper irrigation management, or certain chemicals that have been used in excess, right? So that you feed it into a software, the software keeps learning, and that way it will be able to predict what is wrong with it over a period of time. So this is how the entire drone and drone AI and an application ecosystem works in real life. Next slide, please. These are few of the companies that are using AI in drones. You can both in the software and in actual drones. You can take a look at them. You can take a screenshot of this and then go through these companies one by one later. Hopefully you've taken the screenshot. Next slide, please. So we'll see about different companies. Pix4D is one of the leading photogrammetry software companies in the world. They give softwares to stitch photographs that are being taken from drones along with their GPS coordinates to create maps, create 3D structures, digital elevation models, digital terrain models, so that you could study how different types of land, their elevation, the slope is there. Pix4D involves algorithms to keep making the maps that it stitches better, AI algorithms. Also, they employ the Hummingbird developed software for farm managers to understand the health of the crop, because disease development in crops happens over a gradual period of time. Early detection is what is necessary, and for that the image of a crop with a reference image would be required, and that way to compare images with a reference image manually will take a lot of time. AI uses that to propose to you or suggest to you what might be the probable problem and the probable solution. So that is what they are doing here. So Shield AI drone assists ground forces and first responders in exploration and data gathering. So what happens is, in first responders, meaning in India like the NDRF or the civil defense or the armed forces, where they have to go to emergency situation, be it disasters or a terrorist strike or anything, that they will either have to find people or see how the building has fallen, so that what is the safest way to evacuate if somebody is in there, or to go into buildings. So this way, their drone helps ground forces and first responders to move. So Airlytics makes AI and machine learning drones for greenhouse management. Now, you know greenhouse, right? Not the greenhouse gases, those glass or plastic houses in which crops are grown, where you need a higher temperature, humidity, and different levels of carbon dioxide levels to ensure that the plants grow properly, right? Now, in India, we see small greenhouses, but in other countries, we might have greenhouses that are acres together, and to stay inside a greenhouse for a very long time is very difficult. It becomes very hot. So using drones, we could collect data, and the thing is, the drone should not hit the wall of the greenhouse. Is very important. So flying inside the greenhouse would be a semi non GPS semi GPS devoid location. So that way, the drone has to be good enough to fly inside. So this company uses this. So these are all different applications, smaller applications that companies have made. Next slide, please. So these are other 4 companies. Ardena is utilizing image processing capabilities and artificial intelligence in railway and wind inspections. So let us say a railway track needs to be in certain dimensions. At some point of time, due to heating, or the ballast has given away, or somebody has purposefully created sabotage, they will find those problems, and the software can do it itself. So the time it would take humans to intervene and find this problem would be greater. The software does that themselves. Skycatch is using AI to identify and track assets and medical deliveries across construction sites. So let us say at some point you put cement, you put gravel, you put sand, you put rods. There are equipment that is stored on the site because there's nothing else built to store this, right? They're all just put on the ground. So how do you, on a day-to-day basis, actively track it, that theft is not happening or it is always there? So, and projects happen somewhere. The main corporate company will be in a different location. With this real-time analysis, you can have a command center at the main corporate office, and then track your assets over your construction sites all over the country or all over the world. So that is always possible. Yeah, so Westpac Group, I was talking to you about the shark spotter. So this is what they have built. It might not be a great problem here in India. I'm not sure, I'm not from the coastal sites, but in Australia, it's definitely a larger problem. People getting attacked by sharks or alligators. So they've built drones that are stationed at the beach that fly at regular intervals, spotting sharks. So DroneSense is a company that builds drones and softwares. So one important thing is here DroneSense uses a software that enables multiple people to collaborate at the same time and use drones. And this can be helped in drone swarming or a swarm search and rescue process. So that there also AI uses to implement different flight paths, and so that they don't collide. Second, it covers more region, and so on and so forth. So that's what DroneSense does. Next slide, please. So we'll see one by one applications, a few videos. Skydio is one of the leading companies in the world, recently valued at $1 billion. They are based out of the United States. Whose drones have excellent AI-based computers on board the drone itself, and they use their obstacle avoidance and detection camera to fly through even the most difficult locations. Can we have the video played? Praveen, please switch on your audio. We're unable to hear the audio. Okay, I think there's some technical issue here. So Skydio has drones that does autonomous inspection of bridges itself, where the drone is flying through the gaps in the bridges. And here we can see the drone following. There's two drones basically, one drone following the athlete and another drone following both of them. So nobody is flying the drone. The drone is being controlled or is flying autonomously. And you can see here, so there's basically an onboard computer on the drone itself. It has, and then you can see this is what the computer actually sees. And that's how it's avoiding the obstacle. There are 8 cameras on the drone. so that it can avoid all types of obstacles. In indoors, outdoor, anywhere, it can keep flying. So that's the beautiful part about it. So this is the first version that they had released. I will show you the second version that came out in one of this video later. Next video, please. Yeah, so I was talking about the platform where you do asset detection and management, right? So here you can see this is real time. This is not post-processing image. This is real-time image, the real-time feed where it goes to a ground station and so it detects vehicles, dumpsters, construction material, building completion level as well. So what they do is like they put a full scale model into the software, and then based on that, the software, AI software is contemplating the approximate completion of the building. So this is real time. That way, any command center that is set up by construction companies at their corporate headquarters can see at different locations what is how much inventory is there, what's the completion level, so on and so forth. Next video, please. This was one of the projects that were done at the Indian Institute of Science along with the University of Cambridge. This is very interesting. Just take a look at the video and then I will explain further more points and stuff. So FPN and SHDL network are different types of deep learning networks. Scatter hybrid deep learning is SHDL. And FPN is feature pyramid network for object detection. Okay, so here what they have done, this is a very interesting use case. So what they have done, they have taken positions or body positions of people, or the position of their hand and to create a 3D model on the computer, which says, okay, if this person is in this posture, then he's trying to attack somebody. If this person is in this posture, he is being attacked. Right? This way you could find out actually who's trying to do what and then track them. This can be deployed for large-scale surveillance in cases of large mobs, or even for nighttime surveillance to spot thieves or molesters or anybody like that. This is a very excellent use case of using drones in here. Now, what happens is once the drone detects somebody has done something wrong or some wrongful behavior, it can follow that person and also live stream the coordinates of the person to the nearest police patrol vehicle. So this is a excellent use case for the police, so that you don't have to have a lot of police patrol vehicles moving about. You could just have like a swarm of drones patrolling the entire state or city, not state, city, or a small part of the city, and then 2-3 patrolling vehicles that could be allotted for that. Next application. Okay, this is what caught everybody's eye for quite some time. This is the Loyal Wingman program of the Boeing company, as well as the Australian Department of Defense and the Royal Australian Air Force. Kindly play the video. That's an unmanned fighter jet, built to assist manned fighter aircrafts in real scenarios. This is being developed in Australia. This could literally change the course of future air wars, or even how aerial combats happen. And this is still in the testing phase. So here, a lot of places you will need to use AI. One is for the entire flight pattern, how the drone can engage in actual air-to-air combat. Who is friend, who is foe, and how do you detect between civilian establishments and other military or other terrorist establishments or installations on the ground. And what do you do when you're being attacked, or what happens when your heat-seeking missile is locked, like an AMRAAM Sidewinder or something like that? And how do you differentiate between tank? How do you differentiate between armored personal carrying vehicles? How do you differentiate between SAMs, that surface to air missile installation? So all of this, that jet has to, basically it has to take decisions that a human would have to do, because this is autonomous. This is not being flown by anybody. Those drones are different. This program is fully built to be autonomous itself. Next video, please. This is drone racing, University of Zurich, where a very interesting use case of dynamic obstacle avoidance plus dynamic pathway.
Combines a convolutional neural network with state-of-the-art trajectory generation and tracking. We demonstrate our method in an autonomous, agile flight scenario, in which a vision-based quadrotor traverses various racetracks with possibly moving gates. Our method does not require any explicit map of the environment and runs fully on board. We extensively test the precision and the robustness of the approach in simulation and in the real world. CNN directly maps raw images to a direction and a normalized speed, which can be scaled by a maximum speed at test time. Direction and normalized speed are illustrated in green in the first-person view image on the right. The network predictions are then used to generate a short trajectory segment in a receding horizon fashion. To test the generalization abilities of the learned policy.
So this algorithm now is learning how to fly through the gates when the gates are being moved.
Dynamically move each gate in a sinusoidal pattern in each dimension independently. Despite the gate movements, our approach can complete the track without crashing. As in the simulation experiments, we test the generalization abilities by deploying the system on a dynamic track with moving gates. In the first lab, the track is in the standard configuration also used for static experiments. While the drone is starting its second lab, the gates are moved and the drone has to adapt its path.
So you could see that they actually moved the gate and then the drone changed its trajectory. So this is the future of drones flying inside your house. Maybe somebody wants a spoon to be given to you. I think a drone can go pick it up and get it from the kitchen.
Again. Same as in the simulation experiments, the system can generalize to dynamically moving gates, also on the real track. To show that the network is precise, We challenge the drone to pass through.
So it's now flying in these conditions as well, where
the drone itself.
The pathway is so narrow, it has to avoid all of that.
And trajectory segments of the quadrotor over time. Already after one lap, the visualized trajectories are misaligned by a large margin. This is due to drift in state estimation and would lead to certain collision in a pure feed-forward setting. However, since our approach plans in body frame, it is not affected by drift in state estimation and can therefore still successfully complete the track. Our approach can cope with a large set of simulated and real environments. Despite large motion of gates, the quadrotor is always able to precisely track them and fly through, even when the vehicle barely fits the gate.
So basically, this is the future where drones will be used to fly in tight spaces and ever-changing environments. So a lot of people have this question: what if a bird comes and strikes the drone? I think that whole point itself will go away when drones are able to avoid dynamic obstacles and predict trajectories of incoming obstacles as well. Next slide. So this is the DJI Metros 300 RTK that I was talking about. This is a small tutorial video, but then this explains how track function works.
When used with ZenMuse H20 series camera, the Metros 300 RTK can provide powerful smart pin, smart track, and location sharing functions to meet the demands in industry applications. Open the DJI Pilot app. Set camera mode to zoom. Tap the gimbal track icon on the top left of the screen to enable smart pin and track. At this moment, the camera will recognize objects in the frame and mark them.
So the AI on the drone is now recognizing objects. Now if you click on something and track, the drone will keep tracking it.
The camera will automatically zoom. So the subject will be kept in the middle of the frame for optimal view.
So here it's even adjusting the focal length of the or the zoom of the camera to keep track of the vehicle. And then if the vehicle keeps moving, the drone also will keep moving with the vehicle.
Track immediately. During Smart Track, the aircraft will keep hovering. Distance between the subject and the aircraft is displayed in the app in real time, and the real-time location information of the subject.
And the best way that they've also done is you just push the forward stick, and then the drone will keep following the vehicle that is or the object of interest. And you don't have to fly it sideways, left or right. You just keep pushing forward, and keep following that in whatever way the vehicle goes.
Tap the orange icon.
This is the smart pin option where you click on the object and it gives you the location or the geographic coordinates. So now what is great about it? See, if I see something, I can only tell the distance. That is also from years of experience, right? But I cannot tell it very accurately. Here with perception, the computer is able to analyze how far the object is from its own position.
Thank you for watching.
Change to the next video, please. Okay, this is a very interesting concept where even thermal images need reconstruction in real time to find people in dense foliage. So this drone is basically coupled with a thermal camera and an AI computer on board. Now, for naked eye, there's nothing visible, just trees. Now, when you move thermal, you can only see small traces of people, but you don't know whether it's people or not. Now, they will do integrated reconstruction of the thermal image. This is an integral image and this is a single image. So there are only certain, like your palm is exhibiting because from your body, your ears, your palm, your feet are what exchange heat with the surrounding. They're like the cooling off parts for you. So with that, an integral image is able to sense what is the orientation of the person. Are they fallen down? Are they walking? Is it really a person? So with that dense foliage, with this reconstruction, you will be able to understand where actually people are. So this can actually help. Now, see, search and rescue is a very complex situation, right? Where let's say you have very thick forests, and the forests are absorbing most of the heat that is emitted from your body, and it becomes a little difficult to find people. Now, in that scenario, how do you make sure your images captured can be immediately enhanced to spot people who need to be rescued? So that's where AI comes in. It keeps learning about from the photographs that you take, as well as stock images that are already available, and human anatomy. You can rebuild the human body's thermal signature at spot, and then have somebody go and take a look at it. That way, the time to find somebody, the crucial time to find somebody before it's too late, is not wasted, right? So that's a beautiful use case that is also there using AI in drones. Next video, please. So this is the Skydio 3D scan that I was talking about. This is a very phenomenal thing that they have introduced. Kindly take it. So a drone is performing a inspection of the bridge and building the 3D image real time. We set surface, we're telling that's the surface of the bridge. Now the drone starting to learn and adapt and will fly inside those parts wherever it's possible between the trusses to reconstruct the image real time. So this is the real-time reconstruction that's happening. AI-based computing is helping in building this image in real time. You can see it's even refining the image as and when more photographs come. Trust me, if somebody had to fly this through all of this, there's a 100% chance we would have crashed it into the bridge itself. I have done bridge inspection, which is a little larger with the Metris 300 RTK. It's really scary to fly even with 360-degree obstacle avoidance, because you never know when wind might come in and then just drift your drone towards the wall. And that's the entire bridge is shot. So you can fully 3D construct the bridge. Next video, please. This is in coordinate setup where so this is fully autonomous flight, right? You just put in where the drone has to fly, and the drone will decide what is the speed at which it has to take off. It will decide, this is a fixed wing drone, so it's not like it will just vertically take off. So it has a runway, it has to fly through the runway, then take off, and it has to cover these waypoints. And you will see there is a different altitude setting at different waypoints that is being put in. So the drone will also have to gain altitude, and gaining altitude will normally happen in flight in circles. Now you can see they will initiate the flight. So they're setting flight speed. So the drone onboard computer will have to adjust for altitude, varying wind velocity, and then crosswinds, then different altitudes at the waypoints that have been set. So they're simulating it. You can see how it's changing orientation based on the waypoints, and then now you can see it's gaining altitude. And then now it's flying at the predetermined altitude. This is fully autonomous. Nobody's flying the drone. So this way you could map large areas. Let's say you have a pipeline, you just put waypoints on the pipeline, the drone will fly over it. It's one of the more simpler functionalities of autonomous missions. Now it will go into a circle to decrease its altitude. And then you can see there's altitude reduction as well. So this drone was basically catapult launch. That's why it didn't need that entire runway. But then for landing, it has to take the runway. So this is another another application. Next slide, please. Okay, this you would have seen in the month of January this year. The Army Day, the Indian Army demonstrated the drone swarm capability that it was building under the IDEX program. The company that built this is from Bangalore, called New Space Technology, Research and Technology, where they have more than 75 drones flying simultaneously, performing different types of missions, and also some drones carrying smaller drones, which the smaller drones are kamikaze drones, which have explosives in them, and then they will find the target, go to it, and then explode. So you can take a look at it. All of this is autonomous, where drones are finding their own targets, planning their own trajectory, and also planning the explosive. Some of them are hybrid drones that are running on fuel as well. You can see one drone drop off from the main system. So these drones can be used for, see that drone, smaller drone dropped off from the bigger drone. So you can have mini swarm capability as well. And also another thing would be, you can use these drones for multiple mission requirements, like payload delivery, for target acquisition, for seek and destroy, for surveillance, for scanning of the field to send back data. All of that is possible. So one swarm will have multiple mission capabilities, and then that will help it. So even larger drones have capability to drop bombs, smaller bombs that could potentially take out the mortar dugout or machine gunner or even fuel dumps, right? So cutting off supplies for the enemy. And then finally, and then basically if somebody even shoots down the drone, there's no loss of life. This project is currently going on with the Indian Armed Forces. Next slide, please. So that is some of the applications. There are numerous applications as well. Applications such as building bridges. Now they are training drones to build cable bridges during times where bridges get washed away. So recently when I was in Uttarakhand flying for the NDRF, so 6 bridges got washed away, right? And we had to use drone for pulling a pilot cable. But then imagine if we could actually build a cable bridge instead, where 5 to 6 drones which have strings attached or ropes attached to it fly in dedicated patterns that could build a cable bridge across, right? You can instantly have cable bridges across, and you can resume logistics, because certain of these bridges are very strategically crucial, and that it had to happen at a very fast pace. So most of our research organizations, including the IITs and the Indian Institute of Science, are building AI-powered drone for various applications. The Rustum 2 also is being developed with AI capability in mind. We have another company in Bangalore called Adya Aerospace. They have a very nice use case where they're using AI-based software to monitor the health of the drone itself. In that way, you know when exactly you have to go, your drone has to go for maintenance. In case it crashed, what would have been the reason? What is the life cycle of your battery, the life cycle of your motor? Is there a certain component in the electronic circuitry or the avionics that might fail faster? So all of this they have been working on. That's a very nice thing that I learned about yesterday, and then I wanted to put in today. So these are a few of the things that are going on here in India, and also softwares that have been developed for post-processing also have AI capabilities. And these are being developed by Indian companies. Next slide, please. So that brings us to the end of the major presentation. I'll just take another 2 minutes. So I started JMA in 2019 to help drone companies grow. We have multiple services that we provide, which are catered to helping the industries scale up. We've put it out there for the aerospace industry, but then our major focus is drones. And even the JMA ESC program that we are now conducting, of which the college webinar series is a part of it, is to help create more awareness for people to take up the cause of drones, to become skilled and to develop certain skill sets that could help literally propel the drone industry in India to become or to be on par with the global drone industry. So this is what was the thought process that I had when I started the company. Next slide. So these are few of the services that we provide. We do pilot training because that's the largest requirement for the drone industry. Apart from that, we do provide aerospace consultation. So we provide the industry with skilled manpower, infrastructure support. We also do market analysis, brand consultation. We set up test sites for them. We do government liaising and R&D support and help in investments at certain points in their growth. We also have a private RC flying field in Bangalore, about 8 acres with a 300-meter mud runway, where if you are I think there are some aero modeling enthusiasts. If you're in Bangalore post the lockdown, you can always come and fly there. That's about us. Thank you. I think next is, okay, so we have 2 more programs that I was talking about. This is the Advanced Drone Pilot Training course. Right now, India needs a lot of drone pilots. We are a training organization. We are not a licensing organization. We provide training to make candidates industry ready so that they can get placed. That's our only agenda, so that drone companies can scale up their services to a large extent. And this is almost a 20-25 day program with the soft skill training and then expertise training in agriculture, mapping, and cinematography drones. Those of you who are interested, you can in the feedback form you can tick yeah, you can type in yes or no. Based on that, my team will get back to you. Next. So this is the Drone 100 program, where we will be interviewing interested candidates. We will onboard 100 interested candidates who want to start their own drone company. It's a 45-day intense boot camp that will run with experts from all segments of entrepreneurship, as well as experts from the drone industry will come and speak to you to help you understand how to build a business, what it takes to build a business, what different applications or services or products you can offer. And also, because as a startup, if somebody starts a business, they forget about marketing, branding, financial discipline, and how to raise funds. All of these are not known. You just start a business and then you try to learn it hard. That's how I did. So I don't want people to go through that. And this is a program that we will be starting in somewhere in June. Select group of 100 people whom I will interview and then onboard, whom we will take them through the 45-day program and then mentor for the rest half of the year. And we look to establish at least 30-40 organizations in India and across the world to spread the possibilities that drones offer in either in a product or a service format. You can also mark yes on the feedback sheet, so that's my team will get back to you. So that's it. We will take questions and answers now. Next slide, Praveen. So you can follow us on the social media pages. You can also note down the number and email address. So follow us on social media to know more about what's happening in the drone world, to read about our blogs, what we are doing to bring in new drone technology in India, and also to evolve the current drone technology that is there in India. And also, we during the lockdown, we've been trying to get some very good FPV footage from our farmhouse that we could upload, and then you can take a look at it. So anything drones, we will be putting there, because a lot of people ask questions, how do we get information or a large amount of information about drones? I think our social media sites become one-stop solution for all of that. You can follow us, and then we keep constantly updated on a day-to-day basis, so that you can learn more about what's happening in the drone world and keep in touch with up-to-date facts about drones. So while we take questions, I think we'll leave this image here for you to go like and follow this. So we can take questions now. We will first take questions in the chat, and then we will try to take questions directly. So Mr. Santosh has asked a question: what's the maximum distance a drone can travel with a remote? Depends on what remote and what radio patch antenna you're using. The standard 2.4 gigahertz with under 1 watt power, you can do maximum of 3 to 4 kilometers. Anything greater than that will require a larger antenna or a more powerful antenna with special permissions. If you're using satellite communication or 4G network, it's basically limitless. So if you're using LTE, then wherever you can get connection, you can always fly. Mr. Manish Jain has a question: what are the advantages of drone surveillance over CCTV camera? Now, multiple advantages. One is CCTV cameras are fixed and have blind spots. Drones don't. CCTV cameras cannot track a suspected person. Drones can. When you have a very large complex, you can't have all the CCTV cameras on Wi-Fi. So you are bound to put cables. The major problems we've seen is rats biting off these cables and then CCTV cameras going bad. And to replace that cable is a hell of a lot of work. And that way, that is also a problem. And flying a drone also enables multiple vision, so multiple capacity payloads to be onboarded onto the drone, right? So you have EO, thermal, and zoom, where you could see in the night, you can see in low light or shift to thermal at the same time, and then still be able to track something. So that's one of the major advantage. And for an entire, like let's say a 3-4 acre plot, instead of having 10-20 CCTV cameras, you can still have one drone. That's another advantage. So anyone has questions, you can ask. Okay, one moment. I think somebody has. Are drone cams like PTZ cams? If somebody could elaborate what PTZ is, I will be able to answer. Somebody from Pune had put in there. What's the battery backup? Depends on the battery that you use. Yeah, somebody was speaking. Praveen, I think we can end the presentation. We'll directly go to the grid view.
Okay, sir. Thank you very much, sir.
Thank you, sir, for the opportunity. I wanted to actually thank you.
Okay, sir.
Started on time, but still went.
Okay, it's a really excellent presentation from you. And really, drones are very much useful in military applications, also in hazardous places where man cannot interact directly.
Correct, sir.
And in many applications like agricultural areas and bioengineering, geographical innovations, there also drones are very much helpful. And it is really helpful for our students. It is totally interdisciplinary because of our students are electrical engineering, and there is scope of electrical engineering in aerospace also. Thank you very much, sir. And it is time for vote of thanks. It's my privilege to thank Mr. Leo Peter Charles, founder and managing director, JMA Aerospace Private Limited. So he spared 1 hour continuously with us. Thank you very much, sir. And Praveen Vishwanath, the co-staff of JMA Aerospace Private Limited. Thank you, sir. And Madam Kanij and the whole team of JMA Aerospace Private Limited organized a webinar for our students. Thank you very much, sir. And I also thank to our office bearers, President H.M. Guru Siddha Swami sir, Vice President Allam Channappa sir, Secretary B. Basraj sir, Assistant Secretary Darur Shantanagowda sir, and Treasurer Gonal Rashekar Gaud sir, for their extended support to organize this webinar successfully. And I also thank our beloved principal, Dr. T. Hanmant Reddy, for his support to organize this event. Thank you, sir. And I thank all professors and the faculty of electrical engineering, and mainly the conveners, Hanmant Reddy, Rashekar K, and coordinators Divakar and Shivkumar. Thank you all. And last but least, very important, our beloved students participated in maximum number and registered more than 150 plus for this event, and they are interested to listen this drone and artificial intelligence. And thank you all my beloved students. And continuously we are organizing webinars with interdisciplinary, and participate and gain the knowledge which will be helpful in future, because drones, artificial intelligence, machine learning, and deep learning are the current trends in engineering and having beautiful scope in research areas in further studies also. Thank you all. Thank you one and all. Once again, thank you to Jane Aerospace Private Limited team, whole team. Thank you, sir.
Thank you so much, sir. So if anybody has questions, you can write to us at info@janeaerospace.co.in. We've also put in the feedback form link. This will help us to make our presentations more better. So request you to give your feedback so that I think we are running another 20 webinars in this entire series. We will be able to make it better for presentation. And also the link will help us to send out details to you later when we present other topics as well. So please do fill the form. Thank you so much.
Mr. Leo, can we have 5 minutes because there are
I think
5
there are,
questions. Can
yeah,
we
okay,
have them
fine.
all? Okay, so PZ is nothing but pan tilt zoom. So he's asking, are drone cams like pan tilt zoom cams?
Yeah, they have those functions. That is all. That is there. And certain drones might not. If you have an FPV camera, it's fixed. But then drones that we use for various applications have gimbals that enable drones to do the cameras to be moved in different directions.
Next, we have Deepanjal Mohanta. So she's asking, precision agriculture is the useful for Indian farmers?
Definitely useful. So I was in Garuda, we made Garuda India's largest agri drone company. We've sprayed 20,000 acres of land. What we realized is they use 200 liters of water per acre of agriculture land. With drones, we brought it down to 20 liters per acre, and 180 liters of water was saved. That's the first thing we did. Second was the entire process is autonomous. We map the boundaries of the farm, and the drones fly all by themselves wherever the pesticide or liquid fertilizer or micronutrient gets finished. That spot is marked. The drone comes back. We refill, and the drone goes back to the same spot where it stopped, and then resumes from there. Now, with multispectral camera, we can stop blanket spraying altogether. So, with frequent flights with multispectral camera and AI-based processing, we can identify the parts of land which have these problems and spray only there. That way, the amount of pesticide itself going into the crop or the land reduces enormously. That way, cost reduces, food becomes better, and the entire process of spraying, the time consumption in the spraying process also reduces. That way, it will definitely help farmers.
The next question is from VVS Jayam. What are the prerequisites for drone industry? You encourage women in tech.
Prerequisites for the drone industry should have a very good passion about drones, sound background about drone tech, and definitely women are welcome. That's one of my greatest wishes, because as of now, major participation is from men, because a lot of work happens in very remote places, and generally women are not deployed there. But now we are seeing a lot of urban applications and even agriculture, where women can be deployed, where let's say you're from rural Karnataka, or if you are from rural Karnataka, you could take up drone spraying in your district, right? That you could do for your village or for your district. That's a very much a possibility. Or you could fly for the police department or do mapping. All of this is possible. Is the only concern is safety, and that is why a lot of companies were hesitant, but that now is completely transforming, where women are also playing major roles in drones.
So we have one last question. This is very much common to you. Have you had any drone accidents previously?
Yeah, we've had quite a number of drone accidents, and that is why we say obstacle avoidance and battery management systems have to be very effective, because major times the crash happens because of obstacles itself. And if we can have a very robust obstacle detection and avoidance system, we can reduce these crashes, because every time a drone crashes, predominantly we will have to change 20-30% of the frame, or the motors would have been gone, or the motors would keep running when it has fallen, and because of that large power drawn and EACs would have burnt out. All of these problems are there. So a better drone is a drone that might crash only once a year. That's what I would tell, or not crash at all. And that is how the entire obstacle detection and avoidance system has to be built up.
Thank you, Mr. Leo.
Hello.
Yes.
Hello. Good evening, sir.
Good evening.
I am Rashmiras from Vanestali University. So my question is, you provide the training. Is it chargeable or free of cost? The training which you provide.
So training. So that's all our business. So all our training is chargeable.
Okay.
And you could later contact Praveen, and he will let you know what are the charges, because we have multiple training programs that we have. Some programs we do free of cost because we want to spread. Some of them are part of our business itself, and then those are all paid programs.
Okay. Thank you.
Thank you.
Thank you, Mr. Leo. That is all from everyone.
Okay, thank you everybody for your time. I appreciate it a lot. Please stay safe, stay indoors, and hopefully we will definitely get over this pandemic. Thank you so much once again to the college for the opportunity. I would like to thank everybody from the college who made it possible for JMA to have this webinar. Thank you so much, sir.
Thank you.
Until next time.
Okay, sir. Thank you.
Thank you to the college, and we would like all the students to follow us on our Instagram page, our Facebook page, our LinkedIn page, and also on Twitter, so that you can check the further webinars that we have in our series. And it will be definitely more useful in terms of knowledge and information, and how you can plan your career in the future. So thank you, thanks to everyone, and thank you for joining the webinar.
Okay, thank you, sir. Thank you very much.
Stay home, stay safe. I hope everyone has logged in or clicked the link to the feedback form. If in case you have not done, the same form link will be sent to the college, and in turn be informed to you. And also we'll be sending in the email if you wish to. Thank you, everyone. We are ending the meeting now.
Okay, sir.
Thank you.
Thank you, sir.